Right, today, after we took our vocabulary quiz, we talked about a couple of properties, commutative and associative. Now, these are properties that you've seen for several years now, but they're not going away. So, on the top section of your homework, practice page 1-8, all we're doing is identifying these properties. Okay, on the first one, we have x plus y equals y plus x. So it looks like the only thing that's happened here is that we changed the orders. We're still adding two terms on each side of the equation, but we're changing the order. We have x plus y equals y plus x. That's going to be the commutative property, C-O-M-M-U-T-A-T-I-V-E. Okay, the way we said we can remember the commutative property is it starts with C-O. We need to think commutative, change order. So CO, change order. Okay, if we move on over to number 2. Okay, now we have 5 times m times n. So the m times n is inside parentheses, but then if we move over to the right side of the equation, we still have everything in the same order, 5 times m times n, but the parentheses have changed. Okay, they were around the m times n, now it's around the 5 times m. So we said that that's going to be the associative property. The associative property. Okay, the associative property we said is when groups change. So the groups on number 2 changed. We move to number 3. Now this is one that we didn't talk about in class today. We have k plus 0 equals k. Okay, we added 0. Okay, so we added something to k, but it still stayed k. That's going to be the identity property. And I haven't been doing this, but I should be saying identity property of addition. And on number 1, this should be the commutative property of addition. I'm just going to put a plus sign for addition. On number 2, we should have had associative property of multiplication. Number 4, we have 3t plus 2r equals 2r plus 3t. Just like in number 1, we're still adding two terms on each side, but the order of the terms changed. 3t, 2r, 2r, 3t. So this is the commutative property. Commutative property of addition. Let's move to number 5. Number 5, we have 6 times u plus 2v equals 6u plus 12v. Okay, well this looks like the distributive property, what we talked about yesterday. So we just said 6 times u and 6 times 2v. 6 times u is 6u, which we have here. 6 times 2v is 12v, which we have here. We had addition and we have addition. So this is the distributive property. Okay, if we move across, we have 0 equals 100 times 0. Anytime you multiply a number by 0, we get 0. That's called the 0 property. That's the 0 property. Moving on over to number 7, we have in parentheses 2a plus 3b, close parentheses, plus 4c. On the other side, we have the same exact thing. All the terms are in the same order. All that's changed is that the parentheses were around the first two terms on the left-hand side, and they're around the second two terms on the right-hand side. Like we said earlier, that's the associative property. We need to specify what type of associative property. Since we have addition, 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 it's the associative property of addition. Okay, moving across to number 8, we have p times q plus n equals q times p plus n. Okay, we had one exactly like this on our notes page today, and it tricked a lot of people. Okay, hopefully we can see pq, qp. The order there has changed, so we know that this is the commutative property. But a lot of people have missed what type of commutative property. We see the plus sign here, so a lot of people say commutative property of addition. But that's not true. If I cover up the plus n and cover up the plus n, what really changed orders was what the two terms, or the two pieces that we were multiplying. the variables here, P times Q, and on the right hand side, Q times P. So it's the commutative property of multiplication. Back over to the left hand side of the sheet. Gx equals xg. We're multiplying two variables on the left hand side. We're multiplying the same two variables on the right hand side, but the order has changed. So this is the commutative property of multiplication. Commutative property of multiplication. Okay, number 10. We have 15 times c plus d equals 15 times d plus c. So it looks like we've changed the order of c plus d, on the right hand side d plus c. So all that's happened is the commutative property of addition. Keep in mind, just because there's multiplication here and multiplication here doesn't mean it's the commutative property of multiplication. What we're actually changing the order of are the two variables being added on the left hand side and on the right hand side. Alright, on the bottom of this page, numbers 11 through 28, we're simplifying. Okay, this might involve us using the distributive property, and it's going to involve us combining like terms. So this is very similar to the lesson 1-7 practice sheet from last night. Remember, like terms are terms that have the same exact variables and exponents. For instance, on number 11, 2x and 9x are like terms. Each of them has an x with an exponent of 1. Alright, if we move to another part of the paper, we'll come back to that one just to make sure everybody's clear here. Number 24, we have 6k squared. That is not a like term with 6k. Just because they have the same variable does not make them like terms. Like terms have the same variables and the same exponents. This term has an exponent of 2. This term has an exponent of 1. Okay, so on number 24, the only like terms are 6k squared and k squared, which we can think of as 1k squared. And 6k, I'm going to underline twice, and 9k. Remember, I've underlining these terms that go together in the same way so that when I combine them, I remember which ones to combine and don't accidentally combine terms that don't go together. So if we finish out 24 before we go back up to number 11, we know that 6k squared and 1k squared can be combined to give us 7k squared. 6k and 9k can be combined to make 15k. So our answer to number 24 is 7k squared plus 15k. And I'll move back up to number 11. 2x and 9x we said are like terms. So 2x and 9x when combined gives us 11x. 5x has nothing to be combined with because there are no other terms that have just a y as their variable. So our answer to number 11 is 11x plus 5y. Okay, let's move over to 12. A plus 9b plus 6a. Okay, a and 6a are like terms. They have the same variables with the same exponents. Remember that if we have a variable without a coefficient written in front of it, that it's assumed or implied that that coefficient is 1. So on number 12, 1a plus 6a is 7a. The 9b has nothing to be combined with, so we would say plus 9b. 7a plus 9b. Alright, all of them look the same similarly, but let's just look at one with fractions just to make sure that that's causing no confusion. Remember that we can enter fractions in our calculator. Just never a bad idea to enter them with parentheses around the entire fraction. Okay, if we look at number 14, just because there's a fraction in front of variables doesn't mean that they're not like terms. On number 14, 3/4 x and 1/4 x are like terms because they have the same variable x with an exponent of 1. When we add 3/4 and 1/4 x, we get 4/4 fourths x. Plus z has nothing to go with it, so I'm going to write plus z on the end. 4 fourths x, that reduces to 1x plus z. And if I have 1x, I'm just going to write that as x plus z. Alright, on number 16. We have some like terms again. We have an m squared and another m squared. Again, keep in mind, like we said a few minutes ago, that m and m squared are not like terms. They have to have the same variables and the same exponents. So this term and this term are like terms. M squared is the same thing as 1m squared. So remember that when you're adding. So 1m squared plus 2/5 m squared, if we want to write that as a mixed number, would be 1 and 2/5 m squared. The 3m has nothing to go with it. It has no terms that are like it, so we'll just say plus 3m. So our answer to number 16 would be 1 and 2/5 m squared plus 3m. You might also see that instead of written as a mixed number in front of the m squared, the coefficient for the m squared, we would have 7/5 m squared plus 3m. Alright, let's move down to some others that use the distributive property. On number 17, we have two terms in front of the parentheses that are just being added, but remember we said to simplify these expressions we need to apply the distributive property anywhere where that applies and then combine like terms. Okay, on 17 we can use the distributive property with this 4 applied across both terms inside the parentheses. 4 times xz would give us 4xz, and then 4 times y would give us 4y. Keep in mind, when we apply the 4 across both of those terms inside the parentheses, we have a plus sign here, so I'm going to bring the plus sign out there with it. Okay, the two terms in front, we can't forget about those. 6 plus 3xz equals, nope, should be a plus sign. 6 plus 3xz plus 4xz plus 4y. Remember, any terms that have the exact same variables and exponents are like terms. I see two of those, 3xz and 4xz. Those can be combined to give us 7xz. The other two terms, the term in front, 6 and the 4y, don't have any terms that are like them, so I'm just going to bring those down. 6 plus 7xz plus 4y. So this would be our answer. You might see it written in a different form, but we haven't talked about doing that yet. You might see it written as 7xz plus 4y plus 6. So I'm going to say this or this. We'll get to writing these terms in alphabetical order at another point in time. Alright, the only thing that might be a little bit different is number 28. On number 28, we still are using the distributive property, but we're using it twice. Number 28, we would say 4 times 2a and 4 times b. 4 times 2a is 8a. 4 times b gives us 4b. So 8a plus 4b. We have a plus sign that I'm going to bring down. 2 times a and 2 times 2b. 2 times a is 2a. 2 times 2b would give us 4b. So these four terms now need to be checked to see if any of those are like terms. See, 8a and 2a, these are like terms, and 4b and 4b are like terms. So the ones underlined once can be added or combined, and the ones underlined twice can be added or combined. So 8a plus 2a give us 10a, and 4b plus 4b give us 8b. Keep in mind, the mistake that several people were making today was when we add these terms, 4b plus 4b. A lot of people are wanting to say 8b squared. Okay, it's not going to be 8b squared, and it's not going to be 10a squared. When we add like terms, we leave the variables and exponents exactly as they were. We only add their coefficients. 4 plus 4 is 8. 8 plus 2 is 10.